All right, that's all the announcements at this time. If you would, please stand. Pledge allegiance to the flag of the United States of America, to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Senior meeting happening right now. All seniors, please report for your meeting. To the common area. All seniors report to the common area at this time.
Okay. Question.
What page was this again?
Oh.
Big whoa.
I got two of my grandkids' new school pictures. All the kids. How did I not?
Okay, I did that. Did I do this one?
So they are. I'm gonna try to get them to Alcoa next year, but with Nathan and Jasmine.
Oh, I did that first.
Jasmine's in third grade. She doesn't know her multiplication tables as well as her grandmother math teacher wants her to. So we were gonna start drilling multiplication tables.
Happy birthday.
They're a mess.
Can we sing happy birthday to Cheyenne?
Is it Cheyenne?
It's not my birthday.
No.
One.
If it's not a birthday, then I'm gonna have to say no.
But what if
Thank
it is?
you.
And she says,
Silly boy.
okay.
Okay. Also, I made another module 15 thing, and of course I didn't change the problems. So you're just turning in the 15.1, 15.2 problems that I had given you before. Don't pay attention to this. The other mistake, because you know it's not just good enough to make one, is I didn't write 15.5 work on here. So
So we don't have to do it. Oh.
no, you don't have to, but I'm gonna grade it.
Okay.
Now, when you make mistakes and leave things at home, I still make that okay. I think I do make it okay.
Bless you.
Yes, I'm gonna hand those out here. Yeah, in a second. Okay. While you guys are working on the review, I'll hand back your 15.1 and 15.2 work. Okay. All right. 15.5.
So no, you know,
Okay, I'm gonna start with, okay, I'm gonna do 17, 18, and 19, is there anything else that I need to do before 17? Any of those problems?
What do you mean in 16?
What? What, I'm sorry? Which?
14 and 16?
14 and 16? Okay, so 14 is one of those problems that you're going to be upset when I do. Okay, so AB is 48. And it wants AVB, so I'm going to write that, angle AVB. And so I need that other arc. I need this one. Okay, what is the problem?
Huh?
What's the problem?
Oh, I dropped something.
Did you find it?
No.
What did you drop?
Oh, here it is. I got it.
Why did it go so far?
I'm assuming.
Yeah.
AirPod or like slide?
Wish I could find mine that easily.
You look.
Okay. Now, sir, did you put that chair down beside you, please? When I look at you, I'm looking through the legs. It's bothering me. When you're, thank you.
You're welcome.
When you're looking at these problems, it's so easy not to see radiuses, like I've said, right? Not to see radii, all the any radius in there. It's also easy to overlook semicircles. And do you see what I outlined in red is just simply 180 degrees?
Yes, ma'am.
Without?
How do you know that?
You told us not to assume.
How did I know that half a
These
circle?
are the
No,
diameter.
like I know, but like, what if it's not?
Okay, and that's a great question because there's not a center labeled, is there?
Yeah.
And I have said you can't call it a diameter or a radius unless you know it's the center. Well, it says the endpoints of the diameter, right?
Oh.
A and B are aligned with stones at the endpoint.
Oh.
So A and B are aligned with stones at the, yeah.
That's
Figure
upsetting.
it out.
No, I'm so glad you asked me that because it just helped me reiterate the fact that yes, you cannot assume just because that looks like the diameter does not mean it is unless you're told in some way. Okay? And then so you got x equals, is this a plus or minus?
Minus.
It's outside the circle, so it's minus.
Okay.
Okay? And then I was told 16, right? Did you find PN? Did you find A? Oh, no, that's 15. I'm sorry. Okay, DE. Okay, so the first thing, when you talk about these inside angles and outside angles, if you draw, okay, you know that the arcs are the ones that, you know, are in between, right? Does that make sense?
Yes.
So it was DE. So I'm gonna put my X there. So I have 89 equals 1/2 X plus 61. Do you see those?
Why did you choose like put the 60, put the 89 equal?
Okay, so I think that this problem, it's really hard to see, but this 89 is this angle. It's not this one.
Oh, okay. No.
Okay, so here's the angle, and when I trace my lines that make the angle, in between the lines will be the arcs that I need to use. Do you see that? And I'm gonna do the same thing for the other one, because I think this is really hard to see. So 18, 178 was X plus 61, 7. So 117 equals X. Okay? Now it wants angle F, right? Is that what it wants? So I'm gonna label that Y. Now, like I said, if I trace my angle, the intercepted arcs are between it. So this and this. I need those two arcs.
Can you just do the 360 thing? Or you just-
And so to find this little piece, I can do 360 minus 61 minus 137 minus 117, and I get that. And what is it?
45.
45?
6.
So y equals 1/2 of 137 minus, this is outside the circle, 45. Okay?
Faster than
Okay?
next time you have to get pay 5 cents
All right, so now let me do 17. You ready for me to do 17?
Yes, ma'am.
Okay, so anytime, I'm telling you guys, if they give you this in a problem, line MS is parallel to line PQ, what have I told you before that it means that you're gonna have to use? If they give you that two lines are parallel, what did I tell you back when we were proving triangles, proving congruency, that you would have to use? What? No, two parallel lines, finish that statement for me.
Never touch.
Two parallel lines cut by a transversal. So you're gonna need, okay, look, remember, two parallel lines cut by a transversal. Okay? And you're gonna need alternate interior angles. And remember, alternate interior angles were like these two or these two. And what do I know about alternate interior angles? They're congruent. Okay? So I'm telling you, if they give you that two lines are parallel, 98% of the time, you're going to have to see this. Okay? And it's going to be the alternate interior angle thing. Okay? It's not going to be the other one. Corresponding, it's not going to be those other ones. It's going to be alternate interior angles. Okay? So, if you see parallel lines, what are you going to look for?
Alternate.
Very good. All right, so my parallel line, and then it said, okay, it's labeled. So my parallel lines are here. Okay? You see it? My transversal is here, isn't it? So if this angle right here is 50 degrees,
NP.
this one
Yeah, that.
is 50 degrees. Okay? Now, that angle is 50 degrees. From here to here is what? 100. Because that's a, multiply by 2. That's a, what kind of angle is this? What kind of angle is this?
That's like inside the circle. So
Inscribed.
yeah, inscribed angle.
On the circle.
On the circle.
It's on the circle. And I know, it's weird. It's on the circle and it's called inscribed, but, okay? And inscribed angles are half of the arc. All right?
That means the other side is 100 degrees and 50 degrees.
Right?
Yeah, yes.
Jackson just talks.
Like RPQ, that would be 50 degrees. And then RP, the circle angle, would be 100 degrees.
No, I don't think that's right.
No.
That's not right because
Wouldn't it be 130?
LR is 170. And if you
Okay,
divide that by
okay, yeah, let me draw this. So LR, arc LR is 170, right?
Yes, ma'am.
So what's PR?
That would be 90.
And half of 90.
PR
That means
is 360 minus 170
90.
minus 100,
it's 45.
which this is 90 degrees. So what's angle P?
45.
Okay, stop with the voice. 45 degrees.
Doesn't it look like 50?
Okay.
Okay,
Yeah.
all right. Let's see. So that's 17 and 18, isn't it?
Mm-hmm.
All right. I also want to look at 19. Now, I know that this arc right here in yellow and this arc right here in red have to equal 360 degrees, right?
Yes.
Ma'am.
And I know whatever that x is, this one is going to be 360 minus x.
Mm-hmm.
Now remember, I only need one variable. As long as I only have one unknown, I can solve an equation, right?
Correct.
Ma'am.
So, 38 equals 1/2. Big is 360 minus x minus small.
Why?
Where's the second X coming from?
Now, I'm going to draw this over here. If I knew that this was 100, this would be 360 minus 100, right?
Correct.
So do you see that
But since we don't
this
know
right
it,
here,
it's just X.
right?
No.
Well, why do you
Why is it
Because
2X?
we don't know if it was 100, you just do 360 minus 100
Okay.
minus 100.
This right here is this arc. This right here is this arc.
Oh, I understand. Yeah.
Sí.
Sí,
señor.
You see it? This right here is the small arc. I'm subtracting the small arc. This right here is the big arc. I can put a set of parentheses. That's the big arc, right? But when you simplify it, it becomes 360 minus 2x. And I can solve that. Multiply both sides by 2. Subtract 360 from both sides. And she's not coming. If she's not here by now, she's not coming.
Yes.
So. 6. Let's see. Is that right? That's not right.
Wait.
Wouldn't that be 280?
Okay. 284, yeah.
Bro.
Minus 284 equals negative 2x. I'll write it over here.
I understand.
Divide by negative 2. I get 142 equals x. Okay? So if this is 142, this is going to be 8, what, 228?
218.
218?
Yeah, 280.
Okay? Do you guys see that now?
Yes. It's just whenever you add the second X.
Yeah. Any other questions in that section? Okay, let me hand out these circles. Alright, now, I need every person is gonna get 2 sheets, okay? I need you to have 2 circles.
English is not good today, but the math is online. What makes that accurate is that's how their things work. Wait, what does it look like? One side, it's like, one side is small, one thing is smaller than the other. It does look bad. Or lopsided. I mean, I would.
Maybe like a
You know?
Yeah, that's what I'm saying. Okay.
That looks a little.
Did we even get any? Did she give?
Miss Sharp,
You didn't give us.
never gave our row sheets.
That's
tragic. You forgot about it. As our ages, it destroys nations.
You don't want to start on there's a little container on it. Okay, now, I'm gonna ask you to draw things on these circles, okay? And I'll tell you which circle I want. I'm gonna say on circle 1, okay, and then I'm gonna say circle 2. Then I'm gonna say circle 3 and circle 4, okay?
I don't know which one, 1, 2, 3.
Okay, sure. Start at the very bottom of the second page I gave you and put 1 there.
I don't
2 is going to be the first circle on the first page.
Oh, okay.
I don't know what page is which though. Does it matter?
You're supposed to keep track.
What? Stop.
Oh,
Are you
shoot.
serious?
These are, I didn't.
No, I'm not serious.
Oh my.
We just got bamboozled. You got bamboozled.
Oh. So we put like 1 and 3 on paper and then.
You know, it's very, very scary to me when I think about when I'm old and in nursing
We're
home.
gonna be running.
You guys are going to be running the
Economy.
and that's very scary.
Hey,
We gotta remember before you get old, it's not people above us. They got everything like you.
Yeah, but when I'm married, anyway,
to be president.
you guys are
I will still vote for Lorraine to be president.
now everybody explain to Jackson which circle is number 1.
The bottom one on the second page.
Why the bottom? First one.
So it's like.
The one to your right is the second page.
So like 1,
Yeah.
2, 3, 4.
No, 1, 2. Yeah.
Okay, look.
Miss Sharp.
1, 2,
Wait,
3, 4.
Y'all are so slow, bro.
You guys, I don't.
She was messing with you.
Yes.
But I'm sorry, they don't know. Bro, and then
Okay. Okay, on circle 1, the first circle, okay? I want you to draw, now, there's gonna be a couple things I ask you to draw, and, if you're having trouble remembering what it is, you guys are gonna talk about it without being, you're gonna use your geometry words, okay? And without being like explicitly saying that, this goes there. Like vertex goes on the circle. We're not gonna say those kind of things. We're gonna try to give each other hints, okay? Without just blatantly telling the answer. We'll talk. We'll see, okay?
It'd be fun.
Alright, so the first circle, I want you to draw a inscribed angle. And if you want, do you guys want me to hand out a ruler?
Yes.
I very much appreciate that, Senor.
I have the flexible one.
No, Rita's not married.
Thank you, Miss Sharp.
That's the first time. No, the first time I said Senor, and then I say, Senora.
Stop, Jackson, stop.
Gracias, Senora.
And that's one of those words behind.
No.
Jackson, stop. Jackson, that's dangerous. Nobody's laughing. It's not scary. It's underneath. You're losing. Swinging. No, that's to be
You're ready to get some wood. I'm sorry.
Nice.
I like
Okay,
you.
alright, so inscribed, I want you to draw an inscribed angle.
I did it.
Okay, I want you to draw a central, and this is still in circle 1. And a central angle.
Where's the metal at?
So a central angle. Okay, so we got an inscribed angle. We've got a central angle on that first circle.
5 inches. 5 inches.
Yeah.
You ready?
No, wait, I'm fixing things. Wait. Now it looks pretty.
Yo, I had to do it perfect.
Playing with my emotions.
Because you eat all your food for one. It's actually pretty close.
Matt, I mean, as long as you're, well, I can't tell you. As long as everything's approximate, I mean, I get that you can't actually pick the complete center. I want a circumscribed angle. Hey, and label these too, by the way. Label your inscribed, central, and circumscribed angle so I know you know which one's which. So now I want a circumscribed angle. Still on circle 1.
Wait, what was the second?
A circumscribed, okay, so let's think about a circumscribed angle.
Does the angle only touch, only part of the circle, does it touch? Is the outside or the circumference?
Okay, so think about, do you guys remember when we did the centers of those triangles and then we drew circles and one was inscribed and one was circumscribed?
It's been a while.
Yeah, so circumscribed, and then remember circumscribed The other place we saw circumscribed angles had to be with that supplementary angle. What was a circumscribed angle supplementary to? Think about it that way.
Wait, okay, you're gonna give me a second on this one thing.
Anybody else think about what we knew about circumscribed angle?
Say it louder.
That's just blatantly thinking.
No, that was pretty discreet.
Huh?
Thank you, Zoe.
That was a.
Yeah, it's good to.
Okay, what Zoe just did is what I don't want us to do. She gave us a good example. Thank you, Zoe. Thank you, Zoe. When y'all were trying to figure out what I was talking about, that's it. Thank you. Okay.
Thanks, bud. Who? Noah?
Zoe. Thank you, Zoe.
All right. Circle 2.
Wait, how are you supposed to circumscribe?
Wait,
Sir with a C. Oh, can't do that.
I got it. No, I got it. Yeah.
Okay, second circle. Ready? Circle 2.
Yes.
I want you to draw a chord. Remember, we're labeling these two. The second circle, I want you to draw a chord.
Why do I feel like I did this activity?
And label it. Why do you feel like what?
I feel like we did summer activity in 6th grade or 5th grade.
Oh.
But just not with like all the new stuff, just with like 6th grade.
Do you spell chord, C-H-O-R-D?
Yes, ma'am. Yes, ma'am, that's how you say it.
Yeah.
Chord.
I want to start.
Alright, I want you to, are you ready?
No, give me a second.
It was the second. You may begin.
Wait, what did you say, Ryan? No, other than.
It's sharp. I'm tracking Saturday. Hard Valley again.
What?
I have a tracking Saturday at Hard Valley again. With the same place twice in a week.
Oh, really?
Yes.
Okay. I want you to draw a tangent to circle 2.
What did you say?
A tangent line. I want you to draw a tangent to circle 2.
And
Let me think back to that page.
Okay. Tangent.
Wait, some hints.
What's a can everybody remember the definition of tangent?
Tangent line.
That's not a definition, you just said it, but I want you to draw a tangent line. So you say tangent line doesn't give us anything.
Wait, what's the name of this thing you talked about?
Anybody got any ideas about tangents?
Is it,
What?
That's what I was writing.
the line that's highlighted here.
Okay, did you guys hear the definition of a tangent line?
I don't really know.
Say it again.
it intersects the circle at one point, he said. He wasn't listening to the podcast. No, you didn't.
Like you said,
Thank you.
This is 4 by 6.
They go with that same thing.
Okay.
It's like a million people in like one room.
Okay, ready? Still on circle 2. I want you to draw a secant.
I don't even know what a tangent line is.
She just told you what a
He
tangent
literally
line.
told us.
Samantha,
You're a second. I don't know if that.
I got
draw her again, Samantha.
point.
Square intersects the circle at 1 point.
1 point.
Or does it not?
Wait a minute. I thought it was 2 points.
No.
They just stop right at the circle.
Wait, which are? I'm not seeing it intersected at 2 points. Oh,
Right.
Wait.
Wait. Is a secant 2 lines?
No.
Okay.
I want you to draw a secant line.
Yeah, okay.
Exactly.
Let me see.
But how do you do it?
I'm
Oh. Hold on your picture.
Thank you, Mercedes.
Which one? Stop. Which one is it?
Point at it.
Which one is it?
Well, she's actually got 2 tangents up at the top circle too.
Stop. Half. I don't. I'm confused.
So that tangent
Why is there so many-
intersect.
It touches the circle at one point, a tangent line.
So that means I have to make it go to this.
A line goes, okay, this is not a line. You erased it. But when it stops, it's not a line, it's a line segment.
That's
Okay, so a line,
Oh, you have to touch the other thing. So I make it touch the cord. No, that's not right. That's not
So
right.
is it like this?
yes, good job.
Well,
Or like this?
Next deal.
What?
Okay.
Wait,
I've never done.
Now I want you to draw secant. Okay, so
This one?
that is not a tangent line. It is.
No, it's just somebody that we use.
Yeah, I think I got my.
Why?
Okay, just ask nicely. It's like right over here.
Right. So this one is this way.
Like, think about it is, if you're gonna skate
Yes. Like,
Bro, at least get one.
see, that's a tangent line.
Give me that.
Here's up.
Okay.
When you realize most robberies happen, they ask for the stuff.
Okay,
But he is just.
Circle 3. I'm gonna write this one.
Okay, word.
What is it?
I didn't mean.
Circle 3. I want you to.
Wait, that's circle 2.
I'm gonna write this out so you can see it.
Is this circle 2? I can.
I mean, circle 3.
Oh.
I want you to draw the inscribed angle of a diameter theorem. Okay, so let's, okay. A phrase is, like we unpack the standards where we take them apart and see, right, unpacking something. So unpack this theorem. What do you know it's gonna have in it?
A diameter.
diameter, what else is it gonna have to have?
And scroll.
An inscribed angle. So what do you think an inscribed angle of a diameter theorem was? What do you think that was?
Inscribed angle that has a diameter in it. Oh, I don't think I was supposed to say that, was I?
So basically, the inscribed angle.
So you can't be asking questions like that.
Okay, so, well, that's all right, say it again.
It's an inscribed angle that has a diameter in it. Like, they're like one and the same.
So like one of the lines in the inscribed angle is the diameter. Is that what you understand?
See,
Does anybody, can everybody think about what that would have been?
Okay, diameter theorem. Isn't
What do we know about, tell me what we know about a diameter.
It's a line that goes from side to side while passing through the center.
What's
No,
that?
isn't
Half
that
simple.
Yeah, and what else do we know? If I drew, if I drew a circle with the diameter, what kind of things can you tell me about? Can you tell me anything about this?
yes, you can say the angle, the measure of the
Yeah.
angle.
This is 180, isn't it? Okay? So now, if I put an inscribed angle in there, do you remember a theorem that talked about that? Anybody? No?
Double.
Okay, so an inscribed angle of a diameter theorem, okay, tells us that that's the right angle.
One of those.
which we
I just wanted you to remember back to this theorem. It's kind of obscure and it's kind of so simple that we kind of lose its place. So that's why I had to put this on circle 3, okay?
So we draw what you drew.
Yeah.
Okay, you ready for circle 4?
Wait,
No, not yet, no.
Wait, do we label an inscribed angle with a diameter?
Yeah. Write that. Inscribed angle of a diameter theorem.
A question.
And it doesn't matter where that inscribed angle is. It's always going to be a right angle. It could be the vertex of that angle could be anywhere on this circle, on this half, right? Or the other half. I could even draw it right there. It's still a 90-degree angle there, okay? It doesn't matter where that vertex lies, okay? If the ends of the angle lie on a diameter, then it's a 90-degree angle, okay? All right, circle 4. I want you to do 2 of them. I'm going to give them both to you. I want you to write the tangent, radius, theorem, and I want you to do the circumscribe angle theorem. Okay, tangent radius theorem. Tangent, radius theorem. What two things are you gonna draw in this one?
A tangent line with radii.
Okay, and what does that theorem tell us?
Helps prove that. Help me out, Jackson knows.
Wait, when you
Oh, I know.
Go on.
The angle made by those two is 90 degrees.
Yes. Tangent radius theorem. If I draw a tangent line to a radius,
See?
Oh.
That's what I was trying to say. but
it's
I
a
didn't-
90-degree angle.
Yes, ma'am. I just like to-
Remember?
words. So like, it's like if you took my name and changed it. I feel that. Like change it and take it. How it doesn't figure out. Hey, Miss Sharp, can I go to the restroom, please?
What?
I use the restroom shop.
We're gonna draw one more. It depends on if you
I
can.
can get it.
Okay.
Is it weird that I never say restroom, I always say bathroom?
I can't say bathroom, because there's not a bathroom there.
Yeah, but still.
Circumscribe
It's not a restroom, I can take a bath.
angle theorem. What's a circumscribed angle?
An angle made by two people.
Circumscribed angle.
So it doesn't have to be.
Whoops, I missed my circle. And this theorem tells us that these two things are supplementary. You could write equal 180 if you want, instead of writing out the word supplementary. Okay? Circumscribed angle theorem.
Oh, I thought that was.
See,
the
that
other
was
guy.
more the ice cream cone. See? That was the ice
I see the ice cream cone, I see it.
Back to ice cream. Okay, now let me hand out the review packet.
Oh, fine. Thank you.
And we can use this for our review packet. This is the very useful
That's
of
why I
this
have it.
activity.
Let's see what they're at today.
It's like that.
Sad? No, sad.
Someone say singing?
Did it?
Yeah.
No.
Okay, so
Boom.
Why is that arrow?
you can
Wonderful.
put it here if you want. Just that one here. And it doesn't have to be, I mean, you can put your point here and then you do this, right?
Think about it like 15 years, get you guys gonna grow up.
You know what?
Grow up. And I'm gonna be like 30.
Being child
It's gonna be sad.
Um,
we already.
No.
Oh, am I passing out?
Yeah.
I'm gonna have to go back to school. Okay, so you could put,
Yeah, we.
you put one here,
Where's F at? Is that the line? Yes,
and then
it is.
draw the tangent line.
Where's that? And one. He's still alive.
Dude, it's literally on the board.
So,
It's 11:30.
yeah.
We're all rapid to go and then. Would you like your room?
Yeah, I should have made the circles maybe a little smaller. You know, that you could get, but.
I'm getting it.
Okay, so I hope that helps, kind of clarify things in your head. I'm going to put the answers to the review on. I'm also up here on the board going to put just a little, study thing. Like what, I'm gonna sum up all the theorems right here, okay? And you guys can come and get a picture of that when I'm done, okay? But I didn't want to do